All right, here we go. Progressive JSON. I'm very curious. What is progressive JSON?
Antifa JSON is coming next.
Okay, shut up. Do you know about progressive JPEGs? Here's a nice explanation of what progressive JPEGs is. The idea is that instead of loading the image top to bottom, the image instead is fuzzing at first and then progressively becomes more crisp. What if we have the same idea to transferring JSON? This sounds insane to me. By the way, I just want you to know, like off the rip, I don't see how this can work. So I don't even know what to think about when I hear these words, especially when you compare it to JPEGs, right? Crisp is a nice word. Crisp is a nice word. Suppose you have the JSON tree with some data. Okay, yeah. You just don't have as many comments. Now imagine you want to transfer it over the wire. Because the format is a JSON, you're not going to have a valid object tree until the last byte loads. Correct. You have to wait for the entire thing to load, then call JSON.parse, and then process it. Oh my gosh, I fear that they're writing Falcor. Oh my gosh, all of a sudden I'm fearing that they're writing Falcor. I swear to that all that is good and holy, if paths start coming down where to load a subtree, I'm going to lose my marbles, okay? The client can't do anything with JSON until the server sends the last byte. So for those that don't understand that, why that's not immediately obvious, here's a really obvious thing. Pretend you have a megabyte worth of text that you need to send down for whatever reason you're sending down a megabyte. You can't parse it until you get the closing parenthesis, right? An exception will be thrown. You can only parse JSON once you get the whole thing. This is opposite of something like Captain Proto or flat buffs. Flat buffs allow you to simply download the data and then you don't have to parse anything. You just simply have the data and you can act on it, which is a bit different. But they still all require you downloading the entire thing before you can do anything with the data. And so that's kind of always been the problem. So I'm very curious about this. The client can't do anything with JSON until the server sends the last byte. If a part of JSON was slow to generate on the server, i.e. loading comments, took slow database trip, the client can't start any work until the server finishes all the work. True. That's true regardless of the JSON to be true. Would you call that good engineering? And yet it's the status quo. That's how 99.999% of apps send and process JSON. Do we dare improve that? Well, I mean, a lot of apps just simply don't load comments. They load it as a second call. Like they're fine with an N+1 call due to how slow those things are and the fact that comments aren't the first thing people go for, right? Like, that's crazy. Yeah, that is crazy. I actually think it might not be this intense. From PWA to PJA, progressive JSON app. All right, streaming JSON. We can try to improve this by implementing streaming as JSON parser. A streaming as JSON parser would be able to produce an object tree from an incomplete input. True, but I mean, my worry is that you're also building an app that's really complicated. Because even if you could get something that would tell you every time, like say every time a key gets processed, you get a header, right? So you could theoretically have something where you get a top level object, and once it processes header, it then lets you know, okay, here you go. I have an object with header in it. Okay, now I have an object with post in it. It's an empty object. Now I have object with post and content. Object with post content and this, right? You could see how that could be potentially pretty dang slow. If you asked for the results at this point, streaming parsers would hand you this. Yeah. Okay. However, this isn't too great either. One downside of this approach is that objects are kind of malformed. For example, a top-level object was supposed to have 3 properties, header, post, and footer, but the footer was missing because it hasn't appeared yet in the stream. Yes, correct. The post was supposed to have 3 comments, but you can't actually tell whether more comments are coming or if this was the last one. In a way, this is inherent to streaming. We don't want to get incomplete data, but this makes it very difficult to actually use the data on the client. I would assume this makes it very difficult. This would be like an impossible problem because you'd have to have like an explosion of if statements everywhere, right? Like every last place would be an explosion of if statements. However, this isn't too great either. One downside of the approach is that objects are kind of malformed. Yep, we've already read this. In a way, this is inherent to streaming. If we want to get, didn't we want to get incomplete data? But this makes it very difficult to use the data on the client. None of the types match up due to missing fields. We don't know what's complete and what's not. That's why streaming as JSON isn't popular aside from the niche use cases. It's just too hard to actually take advantage of it in the application logic, which generally assumes the types are correct. Ready means complete, and so on. In the analogy with JPEG, this naive approach to streaming matches the default top-down loading mechanism. The picture you see is crisp, but you only see the 10%. So despite the high fidelity, you don't actually see what's on the picture. True. Okay, that makes sense. So it's like loading the full picture versus not. I do want to throw something. Okay, I'm going to throw something completely also outside of the realm here. I will say the fact that we do send down over a megabyte of JavaScript on so many applications, and then the amount of data we send down is just giant. Maybe that's part of the problem. Maybe part of the problem is also the fact that we just send down a lot of data. Maybe we don't have to send down as much data to say the same things. HTMX rant incoming, I'm not going to do it, but you can imagine, at one point, I won a Hack Day award for Netflix by hacking with some coding guy and Alex Wolf to make it so that we could load the entire Netflix UI in 640 kilobytes of data. And you could go to every single display page. You could go to every single thing. And so your entire browsing experience requires no more URL fetches other than images, which makes it a lot faster, which makes it a lot nicer, which makes it a lot smoother. So, but we also went a little bit different. We also inlined a bunch of data and built our own encoding algorithm on top of things. So a little bit different, you know what I mean? Curious. This was also how streaming HTML itself works by default. If you load an HTML page on a slow connection, it will be streamed in document order. This has some upsides. Well, HTML is also hyper resilient, right? This is just like HTML will figure out and go, yeah, this is valid. That's valid HTML. Like, I know you didn't close anything, but I'll just close everything for you because I love you. Because I'm HTML and I'm written in C and I don't break and it's crazy. I love you. Don't worry. I got you, baby. What, you didn't close that div? That's because you don't even have to. I'm just going to do that, okay? Oh, you didn't close that paragraph? Paragraphs aren't even meant to be closed. That's the crazy thing about paragraphs. Paragraphs you can just not close and they work perfectly fine. This has some upsides. The browser is able to display the page partially, but it has the same issues. The cutoff point is arbitrary and can be visually jarring or even mess up the page layout. It's unclear if more content is coming. Whatever below, like the footer, is cut off, and even if it was ready on the server, it could have been sent earlier. When we stream data in order, one slow part delays everything. Truing. Also, I guess I have a question about this one. I'm curious about where or what is the use case. Generally speaking, you get decent enough internet to be able to use most of these very bloated applications in quite a few places around the world, which is kind of shocking that it just continues to work out. I'm always just shocked that the internet works out to begin with. And so I'm curious if you're going to... What is progressive JSON? I want to see it. Stop foreplaying me. Give me the things. Let's repeat it. When we start streaming things in order, they appear. A single slow part delays everything that comes after it. Can you think of some ways to fix this? Progressive JSON. Okay, let's find out. There is another way to approach streaming. So far, we've been sending things depth first. We start with the top level objects properties, and then we go into that object's post property, then we go into that object's comments property, and so on. If something is slow, everything else gets held up. That's not technically true. And what I mean by that is that the depth of the tree does not imply slowness or fastness of any of these things, because you can have a top-level property that's also slow, right? You could have title, you could have description, you could have ratings, and maybe the ratings, Maybe the ratings thing is extremely slow, whereas the comments are extremely fast. And maybe this deep comment array object is extremely fast, whereas this thing is extremely slow. So I'm not sure if depth first really makes a difference here. It's all about, long as you get enough concurrency going for all your requests, it's whatever the slowest request is your longest request. It depends on the DB query. Yeah, in my head, that's the only thing that matters, is that the slowest request always... It contains everything else, and I don't know if that has anything to do with depth. One could argue is it may not have anything to do with depth. So that's why when he says depth first, I'm a bit confused by this. But Dan's also built a lot of stuff, so one can trust some of his ideas. We start with the top level objects properties. We go into the object's post property, then we go into that object's comment property, and so on. If something is slow, everything else gets held up. However, we could send the data breadth first. Suppose we send top level objects like this. Okay. Here, $1, $2, $3 refer to pieces of information that have not been sent yet. These are placeholders that can progressively be filled in later in the stream. For example, suppose a server sends a few more rows of data in the stream. Okay, but I guess my immediate argument to this, A, you've created your own encoding format, which is a thing. B, I think debugging is going to be a bit difficult, right? It's going to be it's going to be a bit unique to that. If you're using HTTP, you're going to have some sort of body parser that knows how to parse the body. Avro already exists. Yeah, I know. We're getting close to already having something that already exists. And I mean, that's been used by a whole bunch of people. I mean, that's used all the time at Netflix even for all their big data stuff. So, I mean, there's my first problem. But B, you also have a second problem, which is that, you're talking about types and stuff. This is also assuming that the type can be a string. Also, what happened if you do send down the value $1 as the answer? What happened if that gets sent down and you get some sort of misparsing? I don't know. I have lots of questions here. I have a lot of questions. I'm worried about, I mean, obviously, I think immediately I would worry about debugging or trying to figure out what's going on. I still feel like you have to build types into your system that are really stupid. Like imagine a header that's an object, and then you have to transform your header from a string to an object. So all of your, they call them types, the type lint of TypeScript saying that you can either be a string or an object. I think it just adds a whole bunch of things to your world, right? Notice that we are not obligated to send the rows in any particular order. In the above example, we send both $1, $3, but the $2 row is still pending. If the client tried to reconstruct the tree at this point, it could look something like this. Okay, so you'd actually have to have something that, interesting. Okay, I mean, there's something weird. There's something weird about this. Theoretically, I like this idea. Also, we're getting really close to. By the way, we're getting extremely close to inventing Falcor because $1 is a path. Oh, brother, we have created a path. Oh my goodness, we are creating Falcor. I can already feel it happening. We'll represent the parts that haven't loaded yet as promises. Then suppose the server could stream a few more rows in. Oh my. Oh my. Oh my. Oh my. Because obviously something like $2 and $4, this is shorthand for not what it actually is. You know that these values, they have to be something a bit more because they're going to have to be paths through this object. There has to be a way for it to understand the difference between these two. This would fill in some sort of missing pieces right here. There we go. Okay. The promise, I mean, this is how I'm looking at it. I don't see how you're getting any less or more work than the streaming thing. And what I mean by that is, let's pretend you are streaming and all you get is a header object, right? All you get is the header, but you get nothing else. You still have the same if statements being like, if there's no post, don't display the post. If there's no footer, don't display the footer. In this one, you would have the exact same problem. The only difference would be, oh, you have a header. Oh, but the posts, they're a promise currently. Okay, don't do anything if it's a promise. What about the footer? Don't do anything if it's a promise, right? You still, it still feels like you're getting the exact same programming. The only difference is that you're looking for undefined. But I will say the following. Is that you do save one thing that's kind of important that Falcor had a really big struggle with, which is that you don't have to worry about undefineds or missing data or data that does not exist. Because in a world where you're fully managing the structure, if something does not exist there, you can't just simply do a check of is it undefined because that means the thing might not even be there when it comes to streaming. So instead you have to have a type value, like a boxed value. Type value undefined, right? So you can actually see the thing working. Do you know what I mean? Like there's a big difference there. So I can see why the promise thing is neat. And then someone also said you could await the promise in your code. Okay, interesting. Using a promise means you need to parse this to JavaScript. No, what would happen? My assumption is that first off, you'd have your own JSON parser, right? Or maybe you'd have some sort of on top JSON parser. Yeah, you'd probably JSON parse, which is faster than loading JavaScript, right? Like you always want to do JSON parse, and it's super, super fast comparatively to any sort of JavaScript. But then it would load that, then it has to crawl your object and look for these like properties that need to be loaded still. And then it would do the whole promise thing, link everything up. And then when the name comes in, it has to link it. Then it has to link the parent and the key to access it. That's how I would at least solve it, which I think is not insane, right? Which would look something like this. You know, you get an object, you get a key, you'd get your promise. I'd construct this promise in such a way that I have reference to the parent, I'd have reference to the key that I'm on, And then when this promise resolves, I would replace this line right here with the promise value. And then that way, if anybody else decides to await this promise, you would just simply get the value back out, right? You just simply get the value out, whereas I would replace it. Now, obviously, the thing that I personally think that sucks is that it would be really hard to have a type definition where your header could be a promise or a string, right? Like, that's kind of a crappy interface, which means that the only way to make this interface nice is that you would have to wrap every single property in a promise and then just always assume that everything's a promise. And you'd have to await everything at all times. Prime just drew a roller coaster. I did. That's at least how I think about, like, because, just like practically speaking, how would this feel? It would feel really annoying if you couldn't do stuff correctly. Okay, there you go. Now, let's see. Now, from the client's perspective, the entire tree would be complete. Correct. But I mean, in my head, this would be a very inconvenient tree because you'd have to constantly be checking the difference between promises and not. But my assumption is that's not what's actually happening here. I must be missing something. By sending the data breadth first in chunks, we gain the ability to progressively handle it on the clients, as long as the client can deal with some parts not being ready, presented as promises, and process the rest. This is an improvement. I'm not sure if this is actually an improvement at all, other than you don't have to box out your values, which... Yeah, okay, so yeah, it's an improvement in the sense that you don't have to box out your values, but I feel like this is still, it feels really broken still. Now we have the basic mechanism. We'll just adjust it for more efficient output. Let's have another look at the entire streaming sequence. Okay, there we go. Okay, we understand this. We may have gone a little too far with streaming here. Unless generating some parts actually is slow, we don't gain anything from sending them as separate rows. Suppose that we have two different slow operations, loading a post and loading a post comments. In that case, it would make sense to send 3 chunks in total. Yes. Right? Yes. Okay, this makes sense. Agreed with all this. Okay, everything that he's saying makes perfect sense. Okay, yes. Setting the slow parts, setting the fast parts. To me, I guess my question would be this. Why can't these be different requests? Like, why do you have to have them have the same data? Why can't this data be stored in some more top-level data store for your site in which you can still have the same object shape, but not all stored into one? That's kind of how I look at it, is that I feel like we're solving a problem, which my guess is that there has to be some sort of view of like GraphQL on this, or some other like data aggregation service that does and makes all these requests to allow it to be faster and like allows this to operate in some certain way. That's at least how I look at it. All right, so we've seen all this. All right, outlining. One interesting consequence of this approach is that that it also gives us a natural way to reduce repetition in the output stream. If we serialize an object we've already seen before, we can just outline it as separate rows and reuse it. Oh gosh, we're back to type value. By the way, type user feels like why not type value? Anyways, it doesn't really matter. Okay, I must be, whatever. It doesn't really matter. This is a very confusing example. I don't understand it, right? Like, why is a header a user info? I'm struggling here. And how does it? If we were to serialize to plain JSON, we'd end up repeating name Dan. Yes. However, if we're using this, okay, so I'm just gonna throw this out here right away. This does not matter. You want to know why this does not matter? I'm gonna give you like a little bit of fact of life. Are you guys ready for this? I got 2 words for you. Okay, that's it. 2 words. gzip. It literally, like, you are just making gzip is all you're doing. You're just hand rolling your own gzip right here. So I don't think you actually get anything extra here. But you do introduce a custom parser, which is objectively slower than JSON and gzip, because gzip is going to run in Z standard, and JSON parsing is SIMD's nuts out of control. Like, I mean, they place them on your chin and slap you at the same time. It's insane. Like, they've made it so fast. JSON parsing is ridiculous these days, right? It is ridiculous these days. I mean, it's extremely impressive, right? So that's why I don't understand this kind of stuff, because to me this feels, well, and in real life, let's just be real. In real life, you don't often get this. I mean, this is literally Falcor, by the way. He is literally about to invent Falcor. You know why? Because this right here is like, well, then why have duplicate objects? Why not just have a pointer to an object? then I'm like, dude, brother, you have just literally created Falcor. For those that don't know what Falcor is, it's really, really simple. And so let's pretend we have the following here. Let's see. Shout out to Falcor. Shout out to Falcor. You know what I'm talking about? Let's go in here and let's go like this. Let's pretend you have the following. You have videos. Actually, you know what? This is actually probably easier in code than it is anywhere else. So let's, do I have something in, let's go like this. Test.js. It's probably easy to specify in this. Const path equals, let's go like this. Videos, 1, 2, 3. Actually, let's go like this. Lolomo, this is like full Netflix right here. Title, description, right? Description, there we go. All right, so this would be a path. And how this would work is that the actual data store underneath would have something like this. Data store would actually equal something that looks like this. Lolomo, correct. But this would be a type ref. Value would be something that looks like this. List, and then some ID, some UUID. Do you see what's happening here? Do you see what's happening here? That means I can go like this. Right? That means I could have list, right? And then I could have UUID, and then I could have 0 is going to be a type ref, right? There you go. Let's see, videos, 1, 2, 3, 4. Right? Do you see what's happening here? Yeah. Hopefully this makes sense. This is what I spent years writing at Netflix. There you go. There you go. You see exactly what this is. Title, Live Free, Die Hard. Bruce, Willie, given it to us. There we go. So this was Falcor. To the exact thing, right? This makes sense, right? Because here's the argument. What if in row 2, oh, actually I missed something a little bit. It should be, sorry, my bad. This should technically be 0. There we go. There you go, right? Because Lolomo 0 should be a reference to a list. List 0 should be reference to a video. Video 1, 2, 3 is a value, right? And then these technically are a type. I think we called them Atom, right? Right, that would be the actual thing. We had to put you had to type value stuff out to know that it's actually a value to follow it or to do something with it. And so the thing about this that makes it so unique is that let's pretend we had path 2 somewhere deep, somewhere way further out. Let's say it was like 7, 7, the 7th list or the 8th list with the 8th item was the same thing. They could both point to the same video, because again, that way you don't send down duplicated data, you send down just one bit of data. Do you know what I'm talking about? Do you know what I'm talking about? Do you need to make it an array? Of course, if you don't make it an array, what ends up happening? You have to build a custom parser, right? So yeah, so I spent years making this. For those that are wondering, this is how we did. This is how mobile web and TV fetching worked for quite some time at Netflix. It's a directed graph. I like to think of it as a forest. Anyways, we could also prune more balanced strategies. For example, to inline objects by default for compactness until we see some object being used 2 or more times. Again, this is where things get difficult. At which point we'll emit it separately and dedupe the rest of them in stream. Again, very difficult to do because that means your server has to keep track of the objects that it has seen, which again is pretty expensive. Again, you are competing against V8. V8. Very fast Makey string. Very fast. Rope string. Very fast. What is that? It's a rope. Make string. Super quick, right? And so it's just something that I can do. Like, that means you probably have to manually control, or you have to manually walk the JSON object. Or maybe you use the JSON callback, and I don't know what that does to optimizations, right? There's like a lot of questions I'd have. This also means that unlike plain JSON, we can support serializing cyclic objects. A cyclic object has a property that points to its own stream row. I'd have to think about what that means. Streaming data versus streaming UI. The approach above is essentially how React server components work. Suppose you write a page with React server components. Yeah, this is how React server components work. I mean, this should be pretty obvious. I assumed that's where this was going. Just because this right here looked like the things I've seen in a lot of the production I've seen with like the output. React will serve out a page as progressive JSON stream. On the client, it will be reconstructed as a progressively loaded React tree. Initially, the React tree on the client will appear like this, right? Then, as load post resolves on the server, more will stream in, right? Finally, we load comments, resolve on the server. The client, the client receives the rest. Okay, that's cool. I mean, technologically, can at least everyone agree technologically that React Server Components is pretty impressive what they have accomplished? Whether or not you like React Server Components, it's pretty cool that they were able to accomplish something like this. It is a very impressive engineering feat. No, guys, you got to okay, just because you don't like React doesn't mean what somebody does isn't cool. Like, technologically, I'd have to think really hard and take a long time to be able to program this correctly. This is a very hard and difficult process, right? So we can hold two things in our mind at once. That's how I think of things. However, here's the kicker. You don't actually want the page to jump arbitrarily as the data streams in. For example, maybe you never want to show a page without its post content. This is why React doesn't display holes for pending promises. Instead, it displays the closest declarative loading state, indicated by suspense. In the above example, there are no suspense boundaries in the tree. This means that although React will receive the data as a stream, it will not actually display a jumping page to the user. It will wait for the entire page to be ready. However, you can opt into progressively revealing loading state by wrapping part of the UI tree in suspense. This doesn't change how the data is sent. It's still as streaming as possible, but when it changes, React reveals it to the user. Yep, so for those that don't know, suspense just allows you to have a nice little spinning thingy. Comments glimmer. Okay, first off, I think the word throbber is a more appropriate term for it, because that's what it's supposed to be, is a throbber. Why are we calling it a glimmer? Okay. I feel like throbber is to moist as glimmer is to crisp. Is that fair? Okay, chat is not saying anything. All right, first post pops in together with the header and the footer and the glimmer in comments. The header and the footer never appear on their own, then comments pop in on their own. In other words, the stages in which UI gets revealed are decoupled from how data arrives. The data is streamed as it becomes available, but we only want to reveal things to the user according to the intentionally designed loading states. I can't believe I've been bamboozled into reading an article about React. You guys got me on this one, okay? You got me on this one. The stuff I hear on the stream, I know. In a way, you can see those promises in React tree acting almost like a throw, while suspense acts almost like a catch. The data arrives as fast as it can in the order the server is ready to send, but React takes care to present the loading sequences gracefully and let developers control the visual reveal. Note that what I described so far has nothing to do with SSR or HTML. I was describing a general mechanism for streaming a UI tree represented as JSON. You can turn that JSON tree into progressively revealed HTML, and React can do that, but the idea is broader than HTML and applies to SPA-like navigations as well. Okay, yeah, I see what he's doing, because this, obviously, for anyone that's programmed that's more of a React Andy, I'm sure we have a bunch of React Andys in the chat. For those that are Reacties, this probably hits home maybe a bit closer than the JSON version, but this makes sense. I mean, it's truly the exact same problem, right? I don't see it as any different between the two. It's just that the only difference is that often when I use data, it's, I'm doing if statements, and so the suspense allows you to be declarative, which doesn't make you have to have all these like kind of branches of traffic or branches of logic. In this post, I've sketched out one of the core innovations of RSEs. Instead of sending data as a single big chunk, it sends the props for your component tree outside in. As a result, as soon as there's an intentional loading state to display, React can do that while the rest of your data for your page is being streamed in. I'd like to challenge more tools to adopt progressive streaming of data. If you have a situation where you can start doing something on the client until the server stops doing something, that's a clear example of where streaming can help. If a single slow thing can slow down everything after it, it's another warning sign. Like I showed in this post, streaming alone is not enough. You also need programming model that can take advantage of streaming and gracefully handle incomplete information. React solves this with intentional suspense loading states. If you know your system that solves this differently, I'd love to hear about them. This is very interesting. I mean, at the end of the day, it's still very interesting. I think the thing is that if you live in a world where you think of things in terms of DOM and then your program kind of reacts to DOM as kind of the React world is, right? The React world, you shape your program in the shape of your tree. Your code follows the shape of your UI tree. I don't think anyone's going to find that to be offensive or out of bounds right there. And so when you think of the world like that, I think this world makes a lot more sense. For me, I don't think of the world like that. I typically build anytime I build something that I've had to like manually do, I'm not just generating a quick AI to just give me the front end because I don't ever want to touch front end code. I often will use something that's like web components, just because I like the feel of them better, because I just make the requests I want and I load the things I want, and my code does not have to conform to the shape of the DOM. But that's just me. So I'm not sure if I'm on the same page. I've never tried Svelte in any sort of real capacity. I've only looked at Svelte in its various small little ones, which I've actually really enjoyed. My small looking at Svelte. Maybe Svelte would be a nice way to just kind of get back into some of these UI programmings that I have to do, and then I'll just be happy about using Svelte, right? And just be like super stoked about that. You know what I mean? Svelte is nice. Yeah, Svelte. I've heard a lot of good things about Svelte. Svelte is so good for this, and was my first thought. Yeah. Backbone, am I right? Am I right, boys? Backbone? Svelte was good before it became Reactified. I don't know anything about it becoming Reactified. I assume you're talking about the runes. Yeah, some people really love Solid. The thing is that I don't think, like, I know we've now switched topics from progressive JSON into React, but I don't think anything's going to beat the convenience of having something like JSX in your code when it comes to front end, right? JSX is extremely convenient. Changed my mind. The thing I don't like about anytime you have JSX is that you also have to have a build system, which I find to be frustrating. Svelte is the worst JavaScript framework aside from all the other frameworks. What is he on about? It's like a Churchill quote. He's just quoting Churchill, idiot, unread slob. Anyways, that was good. That was good. Use JQ. Okay, people keep saying JQ for jQuery. jQuery is not JQ, dog. JQ is much, much different. JSquirty. That is my rapper's name. Okay? They call me JSquirty. Actually, I like this article. This was really good. It was very interesting because now I feel like I understand a lot more about how React server components worked. This was my assumption of how they always worked to begin with. Because if you ever look at, there's all these HTML comments and there's comments throughout the code about where to place things. That's my assumption about how these work, but I never really quite understood how they actually work. And so this was fantastic. I had a great time reading this. Good article. The name is the Brymogen.